So there's two exercises I want to discuss. I'm sure you could get both of these, but I just want to give you a hint, okay? So the first one is, I want you to take the Hamiltonian, apply it to a dagger raised to the power of n acting on the vacuum, and show that this is n omega a dagger to the power of n acting on the vacuum. So you're just showing that a dagger to the n of naught, so let's maybe write it down, a dagger to the n acting on ket naught is an energy eigenstate. That's what you have to prove, of energy n times omega. So that's what you have to prove. So how are you going to do this? Okay, so here's a little hint. Okay, so first of all, H acting on the vacuum is 0 because we've normalized the energy of the ground state, E naught, to be 0. Okay, so if I've got H, a dagger n on naught, I can write this as H, a dagger to the n minus a dagger to the n h on naught, okay? Because the second term is just h on naught, which vanishes. So that's a perfectly valid rewriting. And then we've got h comma a dagger to the n commutator on naught. So can you see that we just keep repeating the same trick? We just keep adding terms so that we can turn the expression we want to evaluate into a commutator. And now when you see that commutator, you shouldn't even blink. You should know immediately, oh, I should be using the product rule. So I'm just going to write down the product rule, and I want you to check this formula, okay? I know you can prove this. So this is just a hint. So you convince yourself, you prove that this formula is correct. And all that this is just the product rule. So there it is. And then just use the fact that the commutator of H with a dagger is omega a dagger, and the result follows immediately. Okay? So that was the first hint I wanted to give you. Now let's come to the second hint. And for the second one, I want you to prove that this state n, which is a dagger raised to the power of n, is n plus 1 factorial square rooted acting on ket naught. Okay? So it's all about proving that the correct normalization factor, oh, sorry, that you shouldn't prove, that you shouldn't be able to prove, because it's not true. That's what you should be able to prove, okay? And it's all about proving that this normalization factor is 1 over the square root of n factorial. And I want you to prove it by induction. So what would you do? You would assume it is true for n. So assume the above formula. And then prove that the state n plus 1 is equal to a dagger to the n plus 1 over the square root of n plus 1 factorial naught. And when you're proving this, it is useful to realize that this can be written as a dagger over the square root of n plus 1 times by n. Okay, so that is the hint. So when you want to prove it by induction, when you want to prove for n plus 1, realize that n plus 1 can be written in terms of state n, and you know that the state n is normalized to 1. Okay, so that's your hint for proving this formula by induction. Good. Let's move on to the next chapter.